Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and hit the subscribe button. That said, let's get into the current video. I'm going to discuss how to find the vertex of a quadratic function. As a quick reminder, the graph of a quadratic function is referred to as a parabola, and there's two general shapes for a parabola. It could open either upwards or it could open downwards. And the vertex is this point that's either at the very bottom or at the very top. So that is the extreme point of it. So again, that's called the vertex. And whether it is the bottom or the top of the graph, the method to find it is the same. Just depending on if it's the bottom or the top, that could be, the maximum function value, minimum function value. That could have some, change what the range of the function is. But generally speaking, the method to find them is the same. So to take a look at how to find these, we have to start by looking at what is the form of the quadratic function. And there's two different forms for quadratic function. The first one is called standard form. Sometimes some authors will refer to this as vertex form. And the standard form of a quadratic function looks like this. F of x is equal to a times x minus h squared plus k. Okay? And the reason this is referred to as vertex form is because the vertex of this is the ordered pair hk. Okay? I don't have to do any work. I can just pick off those two values. Notice that this is the opposite sign of this number, and this is the same sign of this number. So for a standard form, or in other words, a vertex form quadratic function, we can just easily write down what the vertex is. On the other hand, if I have a general form quadratic, looks like the following. F of x equals ax squared plus bx plus c, which of course I can get this by simply multiplying these terms out. But in this case, to find the vertex, we can do one of two things. The first thing I can do is the technique known as completing the square. So let's abbreviate that as CTS for the moment. So completing the square will take a general form quadratic and it will convert it to a standard form quadratic. The second thing I can do is there is actually a known formula that will simply, I just plug certain numbers in and it just spits out what the vertex is, sort of like the quadratic formula. It's not the same as a quadratic formula, of course, but it is just a simple formula to memorize, and I can just plug numbers in. So what I'm going to do is I'm going to go through examples of all three of those. Okay, so for example, let's kind of go in order here. Let's say find the vertex. Part A, I'm going to have a standard form quadratic. In other words, f of x is equal to 3 times x plus 4 squared minus 7. And then part B, I'm going to have a general form quadratic. Let's say I've got x squared plus, let's say, 8x minus 3. And just for a brief summary here, I'm going to use completing the square to find the vertex. And then for part C, let's say I've got f of x is x squared plus 4x minus 1, and I'm going to use the formula, which I haven't written up here yet, but I'll show you here in a moment. So find the vertex, three different scenarios. Let's go ahead and run through each one. Solution for part A. This is in standard form / vertex form, and remember, of course I just erased it, but the idea is that once I have it in that form, I can just go right to the coordinates of the vertex. I just have to remember how I get them. The x-coordinate of the vertex is the opposite sign of the number in parentheses. In other words, it's -4. The y-coordinate of the vertex is exactly this number right here, so opposite and same, opposite sign, same sign, and this gives me -7. So there's my vertex. Okay. Part B. I have a general form quadratic, but what I want to do is find the vertex using the technique of completing the square. So x squared plus 8x minus 3. Okay. Let me go ahead and run through how to complete the square. Since my leading coefficient is a 1, I can go to my first step. If the leading coefficient was something other than a 1, you do have to factor it out first, so that would be an additional step. If you need more practice or more instruction on completing the square, we have plenty of videos on doing that, so go ahead and take a look at those. Since the leading coefficient is a 1, I'm going to write the first two terms, and then I'm going to leave a blank, and then we'll put the -3 on the end. Remember, the idea is I'm going to add and subtract a number, so of course it's the same number that I'm adding and subtracting to keep the expression balanced, and where that number comes from is the coefficient of x. I divide it by 2, square it, and then that's the number that I add and subtract. In other words, I'm going to take 8 over 2 squared and 8 over 2 squared, where I add it and subtract that number. Okay. Now what happens is, well, first of all, 8 over 2 is 4. 4 squared is 16. So this would give me x squared plus 8x plus 16 minus 16 minus 3. And after I do that, I take the first 3 terms and I'm going to group those together and factor them. And then the last 2 terms I'll group together and evaluate. Now, x squared plus 8x plus 16 does factor nicely. Product is 16 and the sum is 8. That would be 4 and 4. So x plus 4 minus 19. Not only does it factor nicely, but notice this is actually a perfect square. X plus 4 quantity squared minus 19. That then puts me in the form for finding the vertex very easily, right? That is standard form. And as I mentioned in part A, all I have to do is take the opposite sign of this number, same sign of this number, and there we go. There's my vertex. Third example, I'm going to use the formula. Again, I haven't even given you the formula yet, but let me go ahead and write that up on top. Erase everything but the bottom one so I don't forget what that was. So part C, f of x is equal to x squared plus 4x minus 1. All right, I don't know how much room I'll need, but let's just go ahead and get rid of that then. So again, find the vertex using the formula. So if I have a general form quadratic, so remember that was the ax squared plus bx plus c, the vertex is given by the following formula. The x-coordinate is negative b over 2a, and the y-coordinate, well, if I think about on the graph of a function, if I give you the x value, which is, say, a, and this is the function y equals, say, f of x, the y-coordinate is just found by computing the function value at that point. So in other words, the y-coordinate would have to be the function value evaluated at this number, so negative b over 2a. All right? Well, let's see, what do we got? Again, remember a, b, and c were the coefficients in descending order of power. So a is 1, b is 4, c is negative 1 for this particular function. And therefore, my vertex is going to be negative, so b is 4 over 2 times a, so 2 times 1. And then, of course, this is equal to 4 over 2 is 2, so this is negative 2. And of course, the y value is then f of negative 2. Or just to kind of complete this up top here, f of negative 4 over 2 times 1. So I just have to compute the function value negative 2. And my vertex is going to be, so if I plug in negative 2, that would be negative 2 squared plus 4 times negative 2 minus 1, giving me negative 2, and then the y-coordinate, well, this would be 4, this would be negative 8, so that would be negative 4 and negative 1, so negative 5. Okay, so that's how I find the vertex in all three of those cases, whether I have it in standard form, I can just write the answer as long as I remember where the coordinates come from. The general form, I have two options. I can either complete the square to put it in standard form, or I can use the formula for the vertex. And comparing these two, I mean, I guess it's, you know, your choice, of course, depending on what your professor says that they want you to do, but it looks like it's about the same amount of work. Probably better to then just put it into standard form, because this is a procedure that's used frequently throughout some, you know, college math courses, and this does provide some other information as well, as far as how to graph it when you get to your pre-calculus course. But at any rate, thank you for watching, and please consider subscribing.